Good afternoon. My name is Waardenburg and I'm presenting here today work that I do together with Attila Maarton from Copenhagen Business School. Work that we do around explainable AI, which we call It Takes a Village. And I will hopefully explain why we called it like that throughout this presentation. But let's start at why we think this is interesting. And that is because as humans, as people, we've always tried to understand the world through different ways. We've used religion for that. We've used logic or rational for that. Ideology is a means through which we try to understand the world. But that all left questions. And in this current age, there's a new, we could say, tool that gave us an opportunity to understand the world in a different way. And that is a technological solution called artificial intelligence. And artificial intelligence is mainly understood as machines performing cognitive functions usually associated with human minds, such as learning, interacting, and problem solving. And with that, we as humans felt like we were moving closer towards understanding the world, because these tools can generate outputs that we as humans seem to not be able to do. But very quickly, we also figured out that these tools come with a problem. And that is the fact that while we try to use them to understand the world, we actually cannot understand the tools themselves and how they reason. And because of that, recently, quite some scholars have become interested in what is called explainable AI. The way in which the AI systems reason and figuring out how that happens. And there are generally two kind of streams in that. The one stream is more governmental, regulatory based, focused on the ethics of AI. And on the other hand, it is more computer science based. So the governmental and the regulating part is really about how can we make these tools more transparent. The computer science side is more about how can we generate tools and create tools that are explainable or more transparent in the first place. And both streams actually try to understand the same thing, but from a different perspective, and that is the mathematical relationship between, on the one side, the inputs of AI systems, and on the other hand, the outputs that they generate. So how do these AI systems come to these outputs? And they all try to unpack that relationship, which is a mathematical problem. But they all, or not all, but a lot of them come to the conclusion that understanding that mathematical relationship is very difficult, if not impossible, especially if the tools become more and more advanced. If you talk about deep learning, understanding the mathematical relationship behind input and output becomes very difficult. So a new question is arising, and that is, do we even need explanations in the first place? Because they become so impossible. Shouldn't we find ways to use these tools without having an explanation? And what does an explanation then actually mean? We in our work have seen in our empirical work that that question, do we need an explanation in the first place, can be answered with a straight yes. If people want to use AI tools in their daily work, they need some kind of explanation, some kind of way of understanding how these tools came from input to output. So we think that this question is not the question that we should ask, but actually we should ask, who are involved in explaining in practice? So how do explanations come about if these mathematical relationships are so difficult to understand? So how do we then create explanations and make them work in practice? To give you a bit of an understanding of what we build on, I will give you one case in this presentation, and that is based on the crime anticipation system, a predictive policing tool used in the Netherlands. It's been implemented a couple of years ago, and the idea is that it can predict a week in advance where and when certain types of crimes are most likely to happen. That had a massive influence at the Dutch police, with a lot of different groups involved in using this tool, for example, and a lot of different crimes that they could predict with it. The most important aspect of that being that there was a lot of data generated of these crimes. So it was a specific type of what they call high impact crime, happens a lot, has a lot of influence. And this has been implemented all over the Netherlands, all over the different police stations. But what we are trying to show you today is not only that it's been implemented, but also how do these police officers then use such a tool in their daily work, because these tools are not that straightforward if you think about police work on a daily basis, which is more action oriented and wanting to catch thieves. Let me look into the issue that we are talking about. That issue is car burglaries. The police station that I followed for 3 years had a large decrease in almost every type of crime that was related to this predictive policing system, except on the issue of car burglaries. They kept on having issues, and the system kept on predicting these car burglaries. The question was, while the police at some point saw the relevance of these predictions, they didn't really know why, because these predictions kept on coming up. But as I said before, it's very difficult to understand why these predictions are generated in the first place. So the police kept on asking, okay, we see these predictions, but why? Instead of just having one prediction going in the street and then catching the car thieves, they had to really dig deep and figure out what the causes might be of these car burglary predictions. For example, they had a whole new role within the police of people trying to make sense of these AI systems, talking to police officers, looking into the police databases to find out reasons why these car burglary predictions could pop up. Of course, not only the car burglary predictions, these people were related to all kinds of predictions of the AI system. And next to that, police officers were sent into the street to also make data, to go and patrol and look for signs that could indicate, for example, reasons why these car burglaries showed up in that area. So they had to gather data to figure out what could be a reason. On top of that, it wasn't only these people, but they also actually looked at, for example, camera footage and figured out that it was a specific type of parking garage where this happened, and a specific type of light gray car that was constantly involved in the car burglaries. So over time, while they were figuring out more and more details about this, they came to more and more explainable elements of these car burglary predictions. But it took some time and it took some effort. I do have to say that in the end, they did end up in a chase in which the car thieves were actually captured and also were actually convicted of this crime. But this took a while. And that is the funny thing about this story, because as we all focus on explanations as a key feature of AI systems, which can kind of be put upon these AI systems from one moment to the next. So you have a prediction and you have an explanation. What our story actually indicates is that creating an explanation that in the end leads to an actionable outcome, like the chase that we saw, is a process of months. In our case, it started in February and it ended in November. So it's 8 months of work that go into the predictions of one specific topic to figure out all the little details that in the end help you make sense of these predictions. So an explanation is not a straightforward feature of an AI system that you can just unpack by looking at the mathematical relationship, but it includes a lot of different actors and a lot of different activities before you come to a reasonable and sound explanation of such a tool. So what do we say about explainable AI then? Well, we say that explaining AI includes much more than the mathematical relationship between input and output. It includes also the behavior of the criminals who need to repeatedly drive in the same car, for example, to see that this car is related to these kind of predictions. And with that, we just say that explainable AI is a relational, longitudinal, and ongoing concept instead of a key feature of a system. And then coming back to our title, it therefore takes a village to make an AI system work in practice. That is it. If there are any questions, please feel free. Thank you for listening.